Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about what is Linux as an operating system. So let's dive right into it. Well, first, before we go into Linux, we have to understand what created it. What is at the core of Linux? Well, it's a brainchild of Linus Torvalds, this guy basically. Now, idea is this is gonna be free. Now, free is quite a easy thing to understand. It's just free. Don't pay for it, but that does not mean everything. This is free plus open source. What does open source mean? Think of it this way. Open source simply means you can open the code and there will not be any restriction, DRM or things of that nature which will be blocking you. On top of that, you go there, you tamper with it, you edit it and you package it and re-upload it. They will not come after you. It's completely free. You cannot sell it. You can sell services, but you cannot sell the damn code again. Like you took someone else's code, you modified it, you can't sell it again, but you can add it freely. There is a license agreement behind this. So that's the core aspect. It's open source. Free part, that's not that much interesting, but open source part is, because even if let's say you're talking about a big company, let's say Samsung, IBM, things of that nature, they have more than enough money to pay for Microsoft. But let's say for some reason certain hardware misbehaves. Let's say the kernel is just not behaving well. Microsoft will not allow them to, like, okay, this is the source code of the kernel. No, you do not go there. And if they went there legally, they will be doing something illegal. So Microsoft can also take them to the court, because that's the property of Microsoft. You cannot tamper with it. You can just use it, but you cannot change it. So for that reason, open source agreement is very crucial for many enterprise level architectures, because you may, like, if you are just a random dude, having pirated Windows, they're not gonna come after you most likely. But if you are someone who's like making, let's say, Netflix like, and you're making boatload of money, Microsoft will come after you, because you are a juicy target. For that reason, open source is very critical, and free is not that interesting, at least on that scale. Now, when you make something open source, there is a serious probability that people will just go YOLO with it. Some modification could be good, but some modification could be like, let's say, even if it was done with good intent, may not be stable enough. Let's say somebody did change the USB system, so it directly boots into USB 3 and you can directly run USB 3.0 pen drive without any issue. But turns out it may brick every computer that is does not have USB 3.0. So for that reason, you have to have some way of managing it, basically guiding it, still keeping it free, but you still have to, like, bro, don't upload this code, or this code is not working, or like we're not gonna package it into the main system, but we'll have this as an option. Choose it at your own risk. So for managing that, or quote unquote guiding it, there is a Linux Foundation. Now you may be like, okay, let's say Linux Foundation is there. How big is it? It's huge. It's huge. It's freaking huge. So that simply means they have to consume money in order to survive. So how the heck that happens? Who is giving them the money? If the content is free, if somebody can legally take it, tamper with it, and legally sell the services, how the heck they are making money? They are making money directly from quote unquote donations. Basically, they have a lot of backers. Now these backers include some big names. You may have heard of them, like AT&T, Cisco, Fujitsu, Hawaii, Microsoft, Qualcomm, Oracle, Samsung, IBM, Intel, Google, Hitachi. Just the gold level, and I have provided the link down below. You can scroll down, and I'm reasonably sure you will find almost every company down there, flat out. So you're like, why the hell these companies are supporting something that is open source? Think of it this way. Open source simply means anybody can look at the code. That's amazing. That simply means if there is a code, if there is a bug, somebody will catch it. Because let's say Microsoft is like, okay, I'm gonna build a kernel and I'm gonna sell it. Awesome. That's what Windows is. But here's the deal: how many people they can have looking into the Windows? Let's say 500 people, let's say 5,000 people, that's upper maximum. Now how many people Linux have looking at its kernel? That would be like 50,000. There is no way in hell your 5,000 will compete against 50,000 people competing on top of that. Same reason, every single company is like, okay, this kernel has to be refined, it has to be polished, and every Tom, Dick and Harry will chip in a little bit. But let's say Intel provided 5 teraflops of computational, just go with that, 5 teraflops they provided. IBM is like 5 terabytes. Now every company is providing 5 terabytes, but as a whole, as a complete system, you are talking about something that exceeds a supercomputer. Same thing will happen here. It's like every company is doing a little bit, not too much. They are not like, let's say Intel is only saying like, bro, I'm only gonna write the x86 architecture code. After that, it's up to you. So like, okay, Samsung is like, bro, I got this. I'm gonna write the code for, let's say, OLED drivers and all that jazz. I got that part. IBM would be like, I'll write the mainframe computation code. All of them are doing what they can do best, and because all of them are pulled into the same resource, that thing becomes magical. Basically, sum is greater than the whole. whole is greater than the sum of the parts. Sorry about that. So this is the whole point. That's why there is money into Linux Foundation. That's why this guy is actually not that poor. And the source, the open source community actually allows it to grow. Basically, it goes from a few computers are using it to every single goddamn server on the planet using it. So that's the whole point. The core is very important. And if you want to go into the history when this was created and all this, I provided Gary Explains video. It was quite interesting. Now, kernel, most of you are not familiar with it. If you are just normal chill user, you do not give a damn about it. Now, what does that mean, kernel, in layman's term? It's basically a bridge between your application and your hardware, basically, so to say. Because if you're making an application in the olden days, like as in like 1970s and all that, like Apollo era computer, everything was one layer. Basically, there was no application, there was no kernel. There was like, this is it, like your watch. Basically, it's very simplified computer. It's only going to do one thing. It does not have the ability to like do other things. But for a computer, you need the ability to do multiple things. That's why it's general purpose computer. So people created a kernel layer. Now this layer, you write a code so it runs on this kernel, and kernel handles the interaction between your equipment, basically in your software and your equipment. Benefit, everything is standardized. Think of it this way. This is like standardizing how USB is standardized. Your USB pen drive will work. Does not matter whether your computer is 11 years old or 50 years in the future. It will work as long as it's standardized. So kernel is quote unquote standardizing this whole system. Kernel is the most important part. Whenever you buy an operating system, be it Mac OS, be it Windows, it always comes with kernel packaged. Kernel is what's talking with your Intel Intel SSD, Optane system and all that. That's done by kernel. So kernel is a more important part. So kernel, that's the whole point. Now it is free and open source. What does that mean here? Here simply means it removes backdoors. Every computer programmer, no matter how good, they will create a buggy code. It happens. It's absolute. It's inevitable. So, but if you have, let's say, 50 checkers, they will check most of the big issues you will find quickly. But small niche things, small nooks and crannies, they will ended up in the code. What does that mean? That simply means if you know the loophole, so to say, you can bypass the security that protects the kernel. And if you reach in the kernel level, you're done. And that's why like security is such a big deal in modern industry, simply because iPhone is not secure, Android is not secure, nothing is secure if every Tom, Dick and Harry can access it. Now why the heck the same logic, if everybody is using it, it's not secure, while the same thing happens in Linux and it becomes secure? Because it's open. Everybody looks at the code. It's like, bro, why the hell there is like a listen to port 49? It's like they're not supposed to be. The printer is supposed to be the port number 50. That's just a rough example. That's the whole point, because every Tom, Dick and Harry is looking into it as like, dude, this driver has a backdoor, or this has something that can be exploited in the future. Or if there is a new issue comes out, let's say malware that can directly exploit some CPU cache cycles, which happened with Intel, you can be like, okay, kernel has this flaw which has been exploited, let's patch the kernel, because kernel is open. You cannot legally do that with Microsoft setup. Here, I got this, bro. That's why it's so secure. That's why entirety of internet runs on it. Like the kernels that are used by, let's say, Amazon or Microsoft Azure and all that jazz, those are indestructible. The only thing you can do to them is like have denial of service attack or some another bug on top of software that could be discovered, but you cannot touch the kernel, because every programmer looked into it. It's like, yeah, this is how it's working, this is open source, and because it's transparent, they were like, what the hell, why the hell there is this much data going here where it's not supposed to, or why the heck there is like permanent file into my hard drive's 32 megabyte cache, why the heck there is a permanent file there? Most likely it's a rootware. So for that's the reason this is so secure, even though like the same logic makes everything else weak, because so many people are using it, but kernel is locked. So that means any exploit means you can exploit so many people. So every hacker is like, yay, free lunch. But again, on Linux it goes back other ways. Like every programmer is looking at it, it's like, bro, what the hell, why the hell this code is there? So that's why on a kernel level you are secure. That's why every Tom, Dick and Harry, which includes NASA, by the way, so they are trusting it. Now, when you take a kernel, you don't use it because kernel is not supposed to be used. Kernel is a bridge between there. So who drives on top of it? We drive shell on top of it. Shell is basically what loads after kernel, and kernel is like, okay, I'm gonna allow you to use the hardware. Something has to talk to the hardware. It's like, okay, do this. So that do this comes from shell. Now this allows interaction with your system. Now whenever you are using Windows and all that, you are also using command line interface. Only difference is that code you are not typing, you are just clicking right click, go to open, create new folder, something like that. That if you open the operating system, you will see that the same thing happened in the command line. It's like, okay, right click, this command would be there. In Linux you can directly go there. In Linux distribution, it's like, yeah, this is the kernel, like literally you type copy directory, open this and all that. This is always happening in every operating system. You just can't see it, it's taken away from you. But in Linux it's open to you. On top of that, there are multiple options of basically shell that you can choose. You can choose bash, which is used by many people. Then you can choose fish. Many people like it simply because it has more colorful interface, much more friendly to noobs and all that. And then you have KSH, and there are many more. So you can choose, pick and choose what you need, specifically what you want. So it's not in terms of Windows, you are fixed with what they have. It's like if they give you something and you're happy with it, awesome. If they give you something that you're not happy with, even though you are paying it, you cannot change it or you cannot ask anything, like you're stuck. So what about distribution? Now, whenever you say Linux operating system, you talk about generally something like this, Ubuntu disk. This used to come in like, big old magazines, something like this sort of distributions. Now, what does these things actually mean? This means a complete package. Whenever we talk about operating system, we are talking about something that has desktop environment. Below that, there is a graphical user interface. Below that, there is a shell command line interface. Below that, there is a kernel. Now, Windows simply means Windows is gonna give you a packaged thing that contains all that. Mac OS, simply they're gonna give you a package drive. But in Linux, because you can change each aspect, many people create their own custom cells, and many times people create their own GUI, another times desktop environment. So this is the reason. It's almost like an onion where you can peel off the layer, and if you want to run, let's say, a smart sensor, all it's gonna do is monitor temperature. You do not need GUI, desktop environment, all that. And that's why you can have a complete operating system, desktop grade operating system on something as small as, let's say, Raspberry Pi. Simple reason is that, like, because you can go down to the kernel level and you can remove all the things that you do not need. It's like, bro, I do not need this, remove that. For this reason, and there is no encryption into it, because encryption as in, like, you can encrypt the data if you want to make sure that if your main operating system gets bust and somebody steals the hard drive, they can't do anything with it. That's doable. That's up to you. You choose that. But in case of Microsoft, let's say you want to run Microsoft operating system into Raspberry Pi, good luck with that. It will consume all the RAM directly just loading. So you can't do with that. Because we have the mix and match ability, each unit can be fine-tuned. Now, trim the fat for efficiency, that's up to you, because many operating systems, specifically like Ubuntu's and all that, right, they are very good for, like, just getting started. But these are not operating system you're gonna run on your network attached storage. These are good for desktop, but not for servers. So you trim the fat. Like, once you install it, once you learn it, once you know what you're doing, you trim the fat. You're like, okay, I do not need this, remove everything. So you get maximum clock efficiency. Control and fine tune, because till the like last layer, not only desktop layer. In Windows, if you are lucky, if you can control desktop environment. I'll give you one simple example which just frustrates me to no end. Is like, I'm copying large amount of file, I select another thing and I try to copy it. Now if it's in the same directory, it does not stagger it. Basically, it does not wait, okay, let the past copying happen, after that I'm gonna do another thing. I had to use, I think, true copy in Windows 7 era, where it's like, okay, I'm gonna have a system that tells Windows, bro, do not copy a file, like, all the file in one go, try to do one after the another, gives you maximum HP, maximum low corruption rate and all that. But again, Windows does not do that. In Linux, I can write that code that does that, or I can, like, literally tell someone else, like, hey bro, in the group and community, and like, bro, can we do something like this? If enough people are interested, people might actually write the code, and that may end up with a final version of the Ubuntu or Pop OS and things of that nature. Fine tuning, control, all of that is awesome. This is the biggest side effect of Linux. The Linux is awesome, amazing, got tier in server environment, in IT environment, but in desktop it has failed horribly. Why is that? Simply because of this. Because you can make whatever you want. People have made whatever you want. Consequence of that, there are like at least 60-70 distributions that came and disappeared. 60-70 at least. And this image, I have provided the full resolution down below. Be mindful, the image is huge. And you'll be like, okay, this distribution came from 2010 to 2005. 2005 to 2010 it worked, and then it was like 2007 to 2011, then it shut off. So many dead ends are there, and that is the reason you cannot just say Linux simply means this, or Linux, if let's say you are video editor, buy Linux in Ubuntu. If you are like, okay, you are gamer, buy Linux in MintOS. You can't do that, because every Tom, Dick and Harry is tempering everything, and this creates inherently a fragmentation which frustrates people as a common user. For programmer or high level command line user, it does not matter, but for people like everyday Joe, it makes a huge difference. So what should you do as a new user? Let's say you want to start Ubuntu, or you want to start Linux, or you want to start Pop OS or MintOS. You have to understand it. It's completely different OS. The environment that you work on generally in Mac OS, Windows OS, they're built on a different logic, different ethos. Those ethos is like, you do not know what you want to do, we're gonna tell you or we're gonna guide you. That's why the color, the theme, the palette, everything is fine-tuned. There are artists who are getting paid loads of money just to make sure that. And that, like, it's a very important and serious science how to have the UI that conveys what it's supposed to do. Everything should not look confusing and frustrating. You should be able to do it. And there is a very good reason for that. It allows computer to be mass adopted. However, Linux, inherently, every distribution of Linux is inherently different. It's like, you should tell me what I want to do. It's like a computer would be like, bro, tell me what should I do. I'm gonna do it. I'm not gonna guide you, but tell me whatever, I'm gonna do it. Now, once you reach that, once you retrain your mindset, the benefit of that would be, it will be ludicrously fast. Like, if you know what you're doing, this is the fastest system out there in terms of productivity and in terms of just raw sheer amount of work that you can churn through. It's amazing on a god tier, but you have to adapt. The operating system will not adapt, because even if you were like, hey, I can change this and all that, and I don't tamper with this, that's not the whole point. The inherent nature, the inherent design is that you have to learn for it. Like, you have to be like, hey, do this. Linux, do this. Windows is completely different. You have to learn how to do copy pasting or how to block updates and all that. Ubuntu is like, I'm gonna do whatever you ask me to do, but you have to give right commands. So distribution is just a start. Once you reach a certain level of experience, let's say around 3 to 4 months, once you actually started to figure things out, you'll be like, oh, you should try another distribution. You may find it like, hey, for gaming, Pop OS is awesome, but I have an old laptop that is like, I'm barely used, but I do need it working. You will be like, hey, I want to put Mint on that because it's much more efficient. You may be like, hey, I'm running a NAS unit. This is critical work. This should be absolutely stable. You buy something, not buy as in like, you can buy as in service also from Red Hat. There will like enterprise service where they're gonna be on call helping you deal with shutdowns, problems and all that jazz. Or you can be like, there are certain distribution that is made from the core of that benefit. It's ludicrously rock solid, as in like, people generally keep those computer running for like 10 years, 12 years, and then they shut down. So that's the complete reality of it. You have to change your thought process, where you have to like, I have to know what my computer should do for me. It's gonna do it, but you have to know exactly. It's like, I need to rename. You have to tell Linux, dude, rename. It's like, there is desktop environment, which at the first it will look almost similar to basically Windows. Like this, it also has a start menu, all that jazz. But point is, that's not its strength. That's like, its side effect. That's like, it's becoming like Windows. But once you go to command line, once you're like, bro, do this for me, it's awesome. So you have to understand this has real world implementation. If you are like a programmer, if you are like in school and you are like, hey, I really want to see what programming does, this is a best case scenario. Even just installing an application, which has to be like, okay, app kept and do this and that, and you can see that like, oh, this is what programming does. This is how it works in real life, in real environment, in real hardware. What are the problems that you have to face? It's a completely different level of real learning. Like 10 years in Microsoft versus 5 years in Linux, you will be like on a different level in terms of Linux. And it's core of IT, like in terms of as simple things as routers, as simple things as switches, as simple things as like Internet of Things hardware, all of them are running on Linux. So you have to know this. If you truly want to become an IT god, you have to know this. It's not optional. So this was my presentation on Linux as an operating system for a desktop environment. I hope you liked it, learned from it, and your brain is not fried too much. In that scenario, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.